Hello, and welcome to Lesson 5. So Lesson 5 is the last lesson that we are going to be working on for this semester. And we will continue with some ideas of ratios and rates at the beginning of the next semester. So this lesson is broken up into 5 slides, and each one has a video. But what I've tried to do in the past is give some videos of examples and some to check your thinking. And most of these are going to be to check your thinking or to kind of facilitate some of the work that you'll do. So we're going to begin with DN1, which is on slide 1. And to begin with, you should already have annotated the text, looking for key amounts. You also should have set up the fractions in part A. Alex's fraction for lawns to hours and the friends for lawns to hours. If you have all of that done, great. If you don't have that done yet, please do that first, then unpause this video and continue to use this to help you. Okay, so hopefully you've had a chance to complete the annotations and the first fractions. You don't need to have all the answer fractions yet. That's what this is all about. So if you take a look at my screen, you should have that Alex has 3 lawns cut in 5 hours, and his friend cuts 5 lawns in 8 hours. And our goal is to find out what each of them would be able to accomplish per hour. What's their rate? How fast are they cutting? And so to do that, per hour means 1 hour. So I'm going to put 1 in for the hours, and our goal is to find the number of lawns. Well, to figure out what to divide by, I need 5 to become 1 in Alex's fractions, and I need 8 to become 1 in the friends. And so that means that we're going to be dividing by 5 over 5 for Alex. So C equals 5 by division. And for the friend, it'll be 8 over 8, because we want to get the denominator to become 1 hour. No matter what the denominator was, it has to become 1 hour. So we can easily compare the two people, see what they're able to accomplish each hour. Okay, so the C value for the friend is 8. All right, so this is what you should have at this point. And so now what we're going to do is I'm going to be showing you on a whiteboard the long division. And we have to do long division, at least I have to, so that we can get the accurate values for 3 divided by 5 and 5 divided by 8. So I'm going to pause for just a moment and I'll set that up. All right, so welcome back. So now I have set up the numbers that we're going to be dividing across those fractions back on the slides. And so we're going to begin with 3 divided by 5. Now what that means is how many 5s does it take to get to 3? And the answer would be, well, none. 3 is smaller. So then what that means is that we're going to have to split the 3 into the decimals, and imagine what part of the 3 hours, or sorry, what part of these 3 lawns would each of those 5 hours get? So this is 3 lawns in 5 hours. How much of a lawn would be accomplished in 1 hour? And so the number of 5s that goes into 3 is 0, but we can always go into the decimals to find the next part. So if I put a decimal here, I can put as many zeros as I want after the decimal point, because that will keep the same value. This is 3.0, which is the same as 3 wholes. So 5 going into 3.0 is kind of like 5 going into 30. How many 5s go into 30? Hopefully you thought of 6. And so I'm going to put a decimal and 6, which means that it's not 6 whole lawns per hour. It's 6 in the tenths place, 6/10 of an hour, or sorry, 6/10 of a lawn for each of the hours. So 6 times 5 is 3.0, which tells us that our division is done. And so this is equal to 0.6, better read as 6/10, because 6 is in the tenths place. Tenths place means that you need 10 of those size pieces to get back to a whole. So 6/10 is our answer for Alex. Now let's look at the friend. Again, we want to divide a smaller number by a bigger number, which means that we're not going to even have 1 as our answer. It's less than 1 whole. So I'm going to put the 5 here, and split it into 8 parts. And when I split it into 8 parts, that means, first of all, 8 going into 5 doesn't work, so that's 0. So then I have to put decimal. So I'm going to put a 0 here, and now think of it like a 50. How many 8s get as close to 50 as possible? Well, not all of us have our 8s memorized, and it's harder for us to count them. So I'm actually going to show it to help my division. So I have 8, 16, 24, 32, 40, 48. That's pretty close. 56, that's also close, but it went over. And 64, 72. Okay, so this is my list, 9 of the numbers. And like I mentioned, the one that's closest is the 48. And so I'm going to put point 1, 2, 3, 4, 5, 6 here. 0.6 times 8 is 4.8. It's like 48, but with a decimal, and we subtract. All right, now we're going to have 50 minus 48. Well, if I count up 48, 49, 50, I only have to add 2. And so this is 0.2 left over, which 2 is smaller than 8. So now I have to create another 0 and bring it down. So now I look for 20. 24 is bigger than that, so I need to go above that, 16. I'm going to use 16 here. And to make it 0.16, I need to put the decimal here, or the number here after the decimal, 1, 2. So 0.02 times 8 is 0.16. And take away. 20 minus 16, you can count up from 16, 16, 17, 18, 19, 20. Sorry, my thumb is counted, so that's 4. So this is 0.04. If we're thinking about money, this would be 4 cents. Originally, we had 2 dimes. Now we have only 4 pennies left. And we're going to split that 4 pennies by 8, but it's too small. So again, we need to bring down. So I have to create another 0 and bring down. And now I can think of it like a 40, which is in our list. So 5, 1, 2, 3, 4, 5 times 8 will give you 40. So 5 in the thousandths place will give you 40 up to the thousandths place, 0.040. We can subtract. We have a remainder of 0, which means that we found our answer. Our answer is that the friend can complete 0.625 lawns per hour. So you could also read this as 625 thousandths, because it's up to the thousandths place. 625 thousandths. And we're going to talk a little bit more in class about what that might mean for comparing these two. So let me take a quick look at where we are. Okay. So now I'm going to type in the information that we just got. So this is Alex. So that's 0.6 lawns per hour. And his friend 0.625 lawns per hour. Now, both of them have different decimals, and it's hard to compare things if they don't have the same decimal. So I'm actually going to add a couple of zeros, because you can add as many zeros as you want after the decimal, just so that the decimals line up correctly. And now we can better compare them. This is 600 thousandths of a lawn, and this is 625 thousandths of a lawn per hour. And so it looks, according to this, like Alex is cutting. So we can put his answer right here and the friend's answer. And then over on the other side, we'll talk about who is cutting faster or slower. But hopefully you already have a sense based upon the answers here. So go ahead and type in how many lawns per hour Alex is doing. Make sure you keep the decimal. And then same for Alex's friend. And I look forward to seeing you in the next video.